Okay, good morning. Welcome to Math Project 92. Today we're going to keep going with what we did yesterday and talking about binary numbers. Okay, do you remember binary numbers?
Yeah.
All the way back from yesterday?
Yeah.
Okay. So in base 10, we write the number 1.
Yes.
In base 2, it's 1. Well, that's not hard, right?
No.
In base 10, the number's 2. In base 2, we write 1, 0. Do you remember why we write 1, 0 instead of 2?
Because we have a 2's place.
Right, now we have a 2's place instead of a 10's place. So it's 1 times 2 plus 0. 3 is 1, 1. 4 is 1, 0, 0.
5 is 1, 1.
And then all the way through. There's the list. And then I made a special example for 13, which is 1, 1, 0, 1. That means 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1. And 8 plus 4 plus 1 is?
13.
13. Very good. What do you have in your mouth?
Nothing.
Oh, okay. All right. So today I thought we'd have a little bit of fun with binary numbers and then maybe learn a little bit about adding them. But let's look for a few patterns in this. So let's look at what it's like to multiply by 2. Okay? What happens when we do multiply by 2 times 2? So first I'm going to write the numbers 1, 2, 3, 4, 5.
Well, if you multiply by 2, you're going to have base 20 and base 4.
No. We're going to multiply by 2. So the number 1 in base 2 is 1. The number 2 is 1, 0. The number 3 is 1, 1. The number 4 is 1, 0, 0. And the number 5 is 1, 0, 1. Okay? And when we multiply 2, we should get 2, 4, 6, 8, and 10. Okay? Now, so I want you to find what 2 is in binary and write it right here.
Find what 2 is in binary?
Write what 2 is in binary right there. Can you reach it? 1, 0. Okay, great. Write what 4 is in binary.
1, 0, 0.
Okay. Write what 6 is in binary.
1, 1, 0.
Okay. Write what 8 is in binary.
8. 1, 1, 0, 0, 0.
Okay. And now write what 10 is in binary.
Oops. We didn't have really.
Yeah, I didn't. I made it too small.
I'll just put 10 down here.
Yeah, that's okay. Put 10 down there. Okay, 10 is, what is 10?
1, 0, 1, 0.
Okay, I'll leave a little bit more room next time. Okay, so the number 10 is 1, 0, 1, 0. Okay, so let's see if we see any pattern when we multiply by 2. So if we go from 1 to 1, 0. We go from 1, 0 to 1, 0, 0. We go
Well,
from,
actually, I see something.
do you see it? You do? What do you see?
Well, that the number over here, you add a 0 on here.
Yeah, you add a 0 on. What does that remind you of in regular?
Times 10.
Times 10. It's the same as adding a 0. It's the same as multiplying by 2 in binary is the same as is very similar to multiplying by 10 in base 10. And you know what the funny thing is? What's the symbol for 2 in binary?
1, 0.
1, 0. What's the symbol for 10 in base 10?
10.
Also 1, 0. So when you multiply by 2, all you're doing is adding a 0. Well, that's pretty neat. I wonder what happens when you multiply by 4. Okay, sorry about that. I had to go get an eraser. Okay, so now we're going to look at times 4. Stand up. So here are the numbers 1, 2, 3, and 4. And when we multiply by 4, we're going to have to write down the numbers 4. What's 2 times 4?
It's 8.
What's 3 times 4?
12.
What's 4 times 4?
16.
Okay, so I give you a little bit more.
Keep increasing by 4.
Yeah, I give you a little bit more space this time. So here's the binary number for 1. What is it for 4? What is 4 in binary?
4 is 1, 0, 0.
Okay, very good. Here's the binary number for 2. What's the binary number for 8?
1, 0, 0, 0.
Interesting. Here's the binary number for 3, 1, 1. What's the binary number for 12?
1, 1. Well, I think we're adding on 2 zeros every time.
Well, here's the binary number for 12 over here.
Yeah,
What is
1,
that?
1, 0, 0.
Okay. And what about the binary number for 16? Here's the binary number for 4. What's the binary number for 16?
1, 0, 0, 0, 0.
Whoa! So what was the trick for multiplying by 4?
It added 2 zeros.
It adds 2 zeros. And that's pretty sneaky. What?
That's very similar to multiplying by 100 in base
In base 10.
base 10.
Yeah. So multiplying by 4 in base 2 in binary is like multiplying by 100 in base 10. Well, that's pretty neat. And what's the symbol for 4 in base 2?
Symbol.
What is it? What do we write for 4 in base 2? What do we write?
1, 0, 0.
And what do we write for 100 in base 10?
1, 0, 0.
100.
That's funny.
That's funny. So multiplying by 2 is very similar to multiplying by 10. You just add a 0. And multiplying by 4 is kind of like multiplying by 100 because you just add 2 zeros. Okay, so now let's look at a couple other things. Can you tell me
Yeah.
how to tell if a number is even or odd in binary? What can you tell me about the even numbers in binary? And what can you tell me about the odd numbers in binary?
Well, it's switched around except for 1.
What do you mean it switched around?
Well, first in base 10, 1 is just 1. So, okay. Well, 2 is 10, 3 is 11.
Well, no. It's not 10 and 11. It's 1, 0, 1, 1.
Yeah.
Okay. Look for it. See if you see any patterns with the odd. Look at the odd numbers. See if you notice anything. Or look at the even numbers. What do you want to start with? Do you want to start with even or odd? Doesn't matter. Odd. Okay. So what can you tell me? Maybe I'll circle them in a different color. How about green? What can you tell me about the odd numbers? See anything that's the same about every single one of those numbers?
All of them.
Yeah, all of them have one thing that's the same.
They increased by 2.
Well, what else? In binary, in their binary representation, they all have something that's the same. Can you see it? Or do you want to check the evens and see if you can see what's the same on the evens?
Is the evens easier?
No, they're the same.
I'll check the evens.
Okay. So let's look at the evens. What do you notice? Do you notice anything that's the same about all the even numbers? In binary?
Well, they all have zeros
Where?
at the end.
They all have zeros at the end.
And the odd numbers all have 1 at the end.
And the odd numbers all have 1 at the end. So we have a really easy way to tell if a number is even or odd in binary. What is it? How can you tell if a number is even or odd in binary?
Well, the odds have 1 at the end, and the evens have 2.
The odds have 1 at the end and the evens have
I
2.
mean 1. I mean 0.
0. That's right. So if I wrote down a number in binary that was like this, 1 1 0 1 1 0 1 1 1 1 0 1 0 1 0, even though you have no idea what number that represents, that's maybe some really, really, really big number, but you know, you can tell if it's even or odd, right?
It's even.
It's even. So that's pretty neat.
But maybe the Olympiad, maybe if there's a crazy Olympiad book, they might ask you to do this.
Yeah, they might. They might say, what's that number? Well, we'll learn how to figure that out. All you need to do is figure out the powers of 2. Okay, and so now we're just going to look at the very last thing for today, and then we'll do a little bit more of it tomorrow, is adding binary numbers. Okay? So what's the simplest addition problem that you can possibly have?
1 plus 1.
1 plus 1.
Actually, 0 plus 0.
Okay, that's true.
One
We'll
plus one.
look at 1 plus 1. So in binary,
It's 1 plus 1.
1 plus 1. What does 1 plus 1 equal in binary?
1 plus 1.
Is what?
Well, Well, in base 10 it's 2.
In base 10 it's 2, and in binary it's
1, 0.
1, 0.
Oh, it's funny because it always says 1 plus 1 equals 10.
Yeah, it looks like you. That's why I made sure I wrote down that we were doing it in binary. So this is the trick in binary. In binary, you only use 1s and 0s. So when you have your places for the numbers, over here. When you have the places for the numbers,
Yeah.
each place can only be a 1 or a 0. So this might be the number 1, 1, 1, 0, but you can only have 1s and 0s. Okay?
You can't have 2s.
You can't have 2s. Oops, sorry, could you pick that up for me, Annie? You need to reach that. Okay. So you can't have 2s. So if you'd like to say that 1 plus 1 is 2, but you can't have 2s.
Yeah.
Right? So the 2 in the 1's place
Yeah.
changes into a 1 in the 2's place plus 0. So this is saying 1 times 2 plus 0 equals 2. Right?
Of course.
Okay, does that make sense?
Yeah.
Okay. So let's look at, now I'm not going to really explain much of this because this is what we're going to do tomorrow, but let's look at 3 plus 3. And so we know that 3 plus 3 is what?
It's 6.
Okay, and let's look at it in binary.
2 plus 3 is
Is
1,
1, 1 plus
plus 1, 1, 1, 1.
1, 1, 1, 1 plus 1, 1. So we would like to say
Then that equals 22.
that this is 2, 2, but that's totally not right.
That's
So-
using 2s.
Okay, so this is the same as, this means, if we wrote it like this would say 2 times 2 plus 2 times 1, right? Well, this is the same as 4 plus 2, which is the same as 1 times 4 plus 1 times 2, right?
Yeah.
So how should we write this? Instead of writing 22, what should we write?
1, 1. No, I could 1, 1, 0.
1, 1, 0. So that's what we think we should write, is 1, 1, 0. And check, what does 6 equal?
1, 1, 0.
1, 1, 0. Okay? Alright, so addition gets a little bit funny, but there's only one trick that you have to remember. That anytime you have a 2, that's the same as having a 1 in the next step over, right?
Yeah.
Okay? So tomorrow we're gonna try a fun way of thinking that through.
Cool.
Alright, good job today, honey.